Hello, everyone. Welcome to this meetup. My name is Anton. I am co-organizer of the CoruñaJUG user group and VigoJUG user group. Today we have Victor with a very interesting meetup.
Sorry, it was me.
Okay, no problem.
Yeah.
With a very interesting meetup. Just remember, you can write in the chat any question or just say hello, buenos dias. We know Victor understands some Spanish. And also, if you have questions, we'll interrupt Victor just to make them here alive so he can answer it, and he asked for that. So please go ahead, don't hesitate. David and me, we both understand Spanish quite well, so it's not a problem if you prefer to do them in Spanish and we translate them. And this is a new format, so I hope you like it. And that's all from my side. David, please go ahead.
Okay, welcome everyone. And as Anton was saying, this is a new format, a new time that we have chosen. And we are trying this right now in order to see whether it's easier for you to attend our sessions at this time during lunchtime. Maybe it's easier because you are already in your living room preparing to have some lunch and then taking the chance to learn something new with us. And maybe it's easier for you than attending a meetup after the workday. So we have asked this question for you when you were registering, and some of you told us that it's not easier for you to attend at that time. Some of you told us that it's in fact easier for you to attend at this time, and some of you told us that you don't know you were going to by Twitter or by mail or whatever way you prefer. Tell us if it's better for you or not, because this is going to be the first one of many more to come, or not, depending just on how easy it is for you. And that said, let me introduce our speaker today. Today with us is Victor Rentea. Victor is coming from Bucharest, and he's basically a Java champion. He has attended some conference like JVC and Conf, and he's been regular speaker in some of the conferences. So maybe you already know him. You already have heard and learned from him. But today we have him to speak about for our day today. So with no further ado, Victor, the stage is yours. Thank you very much for staying with us.
Thank you for having me. It's much to say I am from Bucharest. I am in Bucharest, but yes, it's suddenly, I mean, all the situation that we're living, it does have some advantages, right? I mean, here I am. I didn't have to fly to you for hours. So yeah. Good. Let's have this. First of all, can you see my screen? I'm not entirely sure. Okay, yeah, thank you. Good.
Oops. Okay, I think we have lost Victor.
Yeah.
Here's again.
I'm just like, I pressed refresh on the wrong window. Let me share my screen again.
Okay. Just you need to share your screen again with us so that I can add it to the screen.
It's done right now.
Okay, there we go. Perfect.
Look closely. How beautiful, pure functions. All right. So pure functions and immutable objects. Now that's a topic that not many people talk about because first of all, it's quite tricky, but it also is way more important for you as a developer, as a designer, than other things like, I don't know, a framework or this is a subtle topic. But I'll just figure out what's about me. I'm a Java champion, and I love simple design refactoring and unit testing. to have a place where to share my passion, I started a community, which is today one of the biggest in Romania, Bucharest Software Craftsmanship community, focusing exactly on these things, which I'm sharing regularly, webinars and discussions. I wanted to do this with you today because I want more interaction, and please indeed feel free to ask absolutely anything when you want to know, right? So I have a website on which I have a blog, some talks, some collection of my best talks until now, and some other goodies. And what I do for a living, right now, I am a trainer and consultant. I started 8 years ago. Of course, my comfort zone is the Java standard development stack, like Spring, Hibernate, and functional programming. And then these are, however, the most requested: design patterns, clean code, and unit testing. These are very deep topics that I can practice in many languages. Just before you today, I discussed clean codes in PHP, for example. That is very interesting because the principles are the same. Really. Okay, also ReactiveX performance and several others. In case you want to know more, and you want to join the training, or you want me for your company, I have websites, and I'm also on the social media, posting there regularly. That's it. Let's come back to life. Your life. Did you ever invert the order of 2 lines and then find out that you just introduced a bug? So just imagine, you move this up and then you get a bug. This is called temporal coupling when this happens. You didn't really expect that here because you see, nothing in the names of these functions tell you that you should call them in the proper order, which is strange. You didn't expect that. This is called temporal coupling. And the actual reason why this happens is that, for example, the check customer changed the customer in a way that made this other function behave differently. But tell me, what would you feel deep inside if you discover that this function changes the argument that you did? It's bad. It's like betrayal. Like he's hacking you in a way. Then another thing which annoys us very much is tests full of mocks, especially on that piece of our logic, which is very complex. That's where mocks annoy us most, when we have to mock 7 dependencies in order to test one piece of our logic. A complex piece. Very annoying. Again, race bugs. People say that only after you had your first race bug, you become an adult. Right? These are famously hard to reproduce, to debug, and to fix. Right? And also, functions that you call multiple times, and by surprise, you get different results from them, even though you give them the same inputs. This is very annoying, very annoying. All of these actually are a sign that you are not using pure functions. Let me explain. 26 years ago, a smart guy had this wonderful idea to separate functions into types, into classes of functions. Commands, he named those functions that returned void. It's pretty obvious that if a function returns void, then you call that function for it to change something in the universe, to do some side effects, we name them. Right, that's why you call this function, right? We want an email to be sent. In contrast, when a function gets you back some results, like this. Now tell me, would you expect that when you search for someone on Facebook, a row is inserted somewhere? You know Facebook, so you expect that. But you don't typically expect that running a search, getting some data, will cause something to be persisted somewhere. It's not obvious for everyone. Or I have another example, even better. Do you remember the times that we used to fly? Oh my God, it was so beautiful. We used to fly. I'm a big fan of flying, and at the beginning, and right now also, I'm flying with low costs. I admit, I'm flying with low costs. And when you search for a flight with Wizz or JetBlue or EasyJet, whatever, you have 15 minutes to complete your reservation. If you miss those 15 minutes and you search again for the same flight, you might get a higher quote, a higher price. Why? Because they saw that flight is being searched for. It's useful, it's interesting, it's being demanded, right? So they adjust their prices. This is annoying. When you first see this happening to you, it's so annoying. I just missed that 15 minutes. Why do I have to pay 10 extra euros for Christ's sake? And this happens because the compute price is not pure. because the compute price returns us different results. So these are the two problems: search that inserts something which is not expected to do, and compute price for the same flight which gets you different results. Right. So Bertenmeyer said that function that returns results should be pure. Now, what the heck is a pure function? A pure function is not allowed to change anything, any state, anywhere, nothing. No inserts should happen, no posts over network, no messages on queues, no files, not even changing the field. Changing the field means it represents a side effect. Whoa. Right, and by the way, we don't care about logging, that's not interesting really. Now, so basically a function is not allowed to change anything. So the only thing that the function can do is to give you back some results. But then comes the fun part. If you give it the same argument, it should give you back the same result over and over again. So in other words, you cannot rely on the current time or random or even a guess over network or even a select in the database might bring you different data next time, because in the meantime, someone might have just inserted a row, of course. Now, the geek term for this rule is referential transparency. Function, we call it referential transparent, is it gives us the same results every time we call it. Right. Now, if you want a simple example of what a pure function really is a mathematical function. It's the perfect example. This one just gives you back data, gives you back results based on the inputs. That doesn't call your mother, doesn't take up garbage, doesn't insert anything, and it will always give you back the same results. Right. Now, there is an unusual confusion here regarding referential transparency. Many people confound it with idempotency. They are not really the same thing. And let me explain. A referential transparent function is a function that, with the following property. If you know that a function returns 3 based on these two inputs, then you are safe to replace that method invocation with 3 everywhere where it's being called. This is what referential transparent means. Now, idempotency is somewhat similar, but not quite. An idempotent function means that after you call that function once, calling it again will not produce any extra changes. So smashing again the base will not make it more broken than it is already. So basically, for example, delete from where ID equals. This is an idempotent function because deleting it again the second time doesn't produce any extra damage. So you get the point, right? Idempotent function can still have side effects, right? Deleting is changing something. However, a referential transparent function means that you can replace it everywhere. Even if you just replace it everywhere, you get 3 less calls to the function, and no bug should occur. This is very important in refactoring. You will see. But first, little quiz. I can't really interact with you that instantaneous, but I will let you some time to think for yourself. So F1 gets an X and returns back X plus 1. And the question is this pure? Well, think of it. Just compute X plus 1. Right. So it just computes the information. Yes, it is pure. And doesn't change anything and returns the same value given the same int, the same X. How about this one? Just think of it a second. So I am getting the D as a parameter. D has an X field, and we increment the field and return the incremented value, basically. But this changes the field. So because the side effect is not pure, it changes stuff. How about this one? D dot increment X and then return D dot X. If this were missing, it would be pure. But this part, we expect it does side effects. By the name of the function, we expect. And if you check inside, we will see that this increment X plus plus. So this is not pure for this reason, because it uses some other functions which have side effects. So you see, purity is something that you can state only if you know what you're doing inside. Right. Good. Query SQL. It may seem that you're just reading data, that you don't do any side effects, and you are right. You don't do any interesting side effects with a query. However, if someone committed a row in between, might get you different results the second time you call. The same query with the same arguments. Okay. Then, but this means also something very interesting, really. In extrapolating, it means that every time you bring data from a foreign system, you don't really know that the same data will come next time. So any kind of external call for data is not pure. Then what about this one? This dot x plus y. But y is a parameter, but this dot x is a field of this. Interesting. Now, if you think of it, it just computes data in return. It doesn't change anything. The question is it referential transparent? Do I get the same value of this I call it the second time? Interesting. It depends. The real answer is it depends. It depends on whether x can change between two invocations of f5. So if x is a different one when you call it again, then giving the same one as an argument might give you different results second time. So if this is immutable, then you are safe to say that this function is pure. Otherwise, you don't know, really. How about this one? We get two arguments, b and y. b get x plus y. Okay, so I'm getting an x. I don't expect I do side effects, right? Because it's get x. This isn't supposed to change anything. I hope. I hope. But how about referential transparency? And you might argue that, wait a second, what if the x field of b changes between two invocations of f6? Then I will get different results. But then I will argue back that if you get a d with a different x, you are effectively giving me a different input. So even if d is not immutable, even if d can change between two invocations, then the second invocation you can argue that it's a different d. It has different values inside. However, things are more clear if data is immutable. Then you can safely say that this function is pure. Interesting. How about this one? Ouch, I did exceptions. So I get an I, and if I is negative, throw exception. Let me think. Throw exception. Exceptions are not returned variable, or are they? Well, they do kind of report back in the color. Yeah, they don't do side effects, that's for sure. And they will always throw exception if I get a negative I. So yeah, that's pure. So you see, throwing exception is pure. And is pure if you always throw for some inputs. So if you always throw for some inputs, then you're right. If this were here, if random less than 0.5, then this is not pure, of course. Right. But the question is, of course, is the catch pure? Wait a second. What do you mean? Yeah, I mean, is writing the catch, if a function has a catch inside, can the function still be pure? A very interesting question. The answer is it depends. It depends on what exception you catch. What do I mean? If the exception that you catch here is always thrown from the block inside, based on x, then you will always enter the catch block. So the catch itself is pure if you are catching an exception that is deterministically thrown from the try block. What am I talking here? And in the meantime, you're trying to eat, right? Folks, please don't. I don't want to cause any deaths in your brain right now, right? It's tough stuff here. Now, if you, however, think of catching another exception on an out of memory, you can't possibly control when these occur, right? This might be a wrong TH mode. This might be an out of memory. You can't really control. So catching uncontrolled exceptions like this will indeed make the catch impure, because you can't possibly know if the catch will run or not. So this is yet another reason for catching exceptions outside of the middle of your code, far away at the boundaries of your use case. Do not pollute your business logic with catches for these kind of exceptions, or either exception or stuff like that. Do that at the boundaries. Now, why do we love pure functions? Well, we discussed what they are. Now let's see what they are good at. The pure function cannot possibly use any hidden inputs. I mean, they will be only plain-sight return values and parameters with the catch about instance function, which can also use instance fields, of course. But the best part is that if you have a function and another function, and these two are depending on each other, the only way they can really depend is the first function return a value which is used by the second function. You see? You can't run into cases in which you invert the order of the lines and you get an unexpected exception. No, if you try to put this line up above, the compilation will crash, right? So there is no hidden temporal coupling between those functions. They are also easier to understand. You don't need to know what things it accesses. We don't need to really know, but what is in the database? No, nothing like that. It's only input values and maybe some instance fields, nothing more. Very easier to test. That's the catch. You don't need mocks. You do not need mocks to test a pure function, because a pure function can only depend on the input argument or the instance fields, nothing else. No dependency, because a dependency is an uncontrolled source of data. Interesting. Because you are not allowed to get out of your machine, you get a point, right? If you get to a database, it's not pure. If you get to a REST call, not pure. Files, not pure. So you only get to remain in the memory. That's why they are very, very fast. Right? So you are free to call them as many times without a performance issue, and also because they are referential transparent. You will see on the next slide. There is no temporal coupling, as I've explained here. And they can also run them in parallel, so no more race bugs for you, because you don't change state. That's what causes race bugs, race conditions. Concurrent modification of shared mutable data. Okay, so why do I love them? Me being a clean code maniac, or the factoring maniac. Whenever a function is pure and fast, it's safe to call it multiple times. So imagine the following scenario. You call a function, you put it in a variable. By the way, don't use var. And then this data, you use this variable, you use it in two places in the code below. If f is pure, you can delete this variable and inline the variable everywhere, calling the function twice. So what? It's pure, I don't care, and it's fast. Right? And mind just that you don't compute prime numbers or do encryption or hashing here. That it might get a bit costly sometimes, but 99% of the functions are very fast. Right? This is called replace temp variable with query. This is from the refactoring second edition book, Martin Farrer, December 2 years ago. One of the refactoring is in this book. Right? Another one. This one calls a function, and the result of that function passes to some big function. What you can do to reduce the number of parameters is to take this call and call it from inside, like this. It's called inlining a parameter. Okay, replace parameter with query. This is a query function. Remember, command query separation. There you go. This is a pure function, so I'm safe to call it multiple times. You are free to juggle. You are free to play with pure function with more comfort than anything else. Because you don't care how many times, and yes, you get to call that function. Interesting, very, very useful. But I know what some of you are thinking now. This is a developer, the senior. This is the senior. Now, let me come back a bit to this example. I've heard people start, folks, I talk to thousands of people, hundreds of teams, and I get to hear all sorts of ideas. And one tech lead once told me, Victor, okay, I get it. But what if a junior joins my team and inserts data in their function? He doesn't know what you're hiring, all right? I mean, what the heck? When you will add an insert to a function, won't you verify where is that function code? I mean, what the heck? What kind of developers do you have? Yeah, I would check. Well, of course I would check. I would see who calls the function and make sure that I don't do shitty things here. Oh, and there is another thing which might help you. Naming. If you have a name which tells that you are computing stuff or computing, I don't find an easy developer that can put an insert in a method named compute. I mean, yeah, he will have a hard time. He will have remorse. But I convinced you. From now on, I will only use pure functions, right? That's stuff. You can't possibly do that. All our applications do change something. There are very, very few applications out there. Maybe some Lambda that you deploy on some class, something that don't really persist. You typically want to write a file, send a message, or insert a row, right? So how do you do it? The bad news here is that there is no strict way to enforce purity in Java. You can't mark a function as being pure and let the compiler check it for you. There is no, if you know of a way, please tell me. I'm really looking for it, but there is no way I know of. So we have to leave it both pure and impure functions. Interesting. How do we then distinguish between them? One way you can use one attempt is by using the names. But there will be cases in which you will have a create order function that, of course, needs to insert an order, but also wants to return back the primary key that was inserted, the ID of the new order. So you can't possibly follow this in production, in real cases, every time. So, however, this is fragile, right? One way you can try to force this, however, is to put a name that will scream at the reader that you are changing stuff. Okay. This will highlight somehow the side effects that you're doing. But this is a terrible name. How about the single responsibility principle? How many things is this function doing? Two things at least, right? So yeah, I think dubious. So I'm not here to tell it bad news. I'm here to tell some good ideas. So you can do better. Now, imagine this is your complex logic. So again, I'm talking about those most complex use cases that you have. Those 20% hardcore use cases that you have to implement. This is your logic for those flows. I want you to try to isolate in the middle of that complex logic a functional core. I mean, all bits of pure functions that compute stuff. All the heavy business logic, all the complex business rules should be inside those pure functions. Leaving outside an imperative shell in which you do all the side effects or the reads that bring random data in, like read from the database. In other words, I want to expose those impurity. I want to expose impurity out of the middle and let the middle pure function. So purify the most complex part of your logic. How? Well, time and random, although technically speaking, they are impure. I didn't find them raising much problems in real life cases. You don't really take decisions based on time and random. So I will silently skip this topic. Now, opening files in the middle of the business logic, I don't think any of you is very comfortable doing that. I mean, what the heck? You are computing some promotion algorithm and then poof, open file. It's gross. Right? What the heck? It's not the point of the business, of the central domain logic. Of course, there are no files in the middle of your logic. But there are database and network calls. How do you handle them? Most use cases begin with a read of data from somewhere, from some data storage. What you can do is to read in the imperative shell and then call a pure function that gets all the necessary data. This will tend to add more parameters to those functions. Indeed, up to a certain point, you might create a new class for this reason. It depends. Then writing results. But again, I'm talking about those complex use cases, those several heavyweight, where 50% of your bugs are. Right? Writing results. Most use cases finish with writing stuff, sending stuff to somewhere. So you can return back the data which was computed and then persisted from the imperative shell. But this is easier to write here, but very hard to do in production, because in production, you might want at the end of the flow to send a message on Kafka, to write a row in a database, to send an SMS, or write a file. How would you do that? Well, one idea is to group all those changes to do in a new class. Again, a new class? And I find people are scared. Do you want me to create a new class? Am I allowed to do that? I find people afraid of creating classes. But again, I'm talking about those most complex use cases. It's a problem, really. We developers tend to use the same tools for trivial cases and for complex cases. Don't do that. Don't do that. Use functions in the middle of this for complex cases. But there is one last horror story. In case you have some functionality which in the middle of some heavy business logic, it wants to read some data or to write some data. What do you do with that? This is impure. You want to take it out from your functional core. How do you do that? Well, that's the bad news. If you ever have that, if you ever need to do a query or a network call in the middle of the business logic, the only way you can do that, really, is to split the processing into two pure functions. These two are pure. It should be blue, really. These two are pure. And you are able this way to drag the read in the imperative shell at the entry point, at the top level of your workflow. What this, however, means is, again, you need to create a class. Very often, the phase one of the processing needs to send a lot of data to phase two. And this typically represents a class, because you can't return too many values from the same function. It depends, but that's kind of the rule. And this has a name. It's called split phasing factor in the Martin Fowler book. Good. So in short, everything that I did, I just exposed impurity to the top level, living inside pure functions. That's the point. To implement as much complex logic as pure functions, internal pure functions, and surrounding them with impurity. Folks, functional co-imperative shell, you can find it on Google, but it's a very, very advanced design idea. Right? And this brings us to the real pain. The real pain, to be honest, I think that's not what really makes our function, most of our functions impure. There's not an intermediary write or read from the database which annoys us most. But what annoys us most is changing object state. Is when a deep function mutates a field, changes a field. Let me walk you to some real world horror stories. So you are inspecting code. That's it. You are looking at the code and you say, okay, if data get x equals 1, you want to figure out by looking at the code whether you will enter this if or not. To find this out, you need to trace what's the value of x in this data. Yeah, data came here, so I need to trace where it came from. It came from D, and then in turn it came from H. Perfect. And back in H, it had the value 1. Perfect. So you say, okay, it's 1, so it will enter the if. It's funny, no, because typically if this data is mutable, there might be somewhere along the way who changes x, of course. Setups, of course. And there are several functions in between. You need to see who changed this x. Perfect. But that's not the worst case. The worst case is when G calls another function, maybe with 3 other functions in between. And somewhere deep in that flow, passing data. Somewhere deep in that flow, someone changes x. And you start cursing and swearing, and your life gets shorter. You live less years and an unhappy life if you see this often. Very evil, very evil. But it can get even worse. But that's the most common one. But it can get even worse. I several times see that. I call a function without providing data. I mean, there is no way this can do anything, any harm, right? Wrong. Look what this guy does. Changes x on a reference that it kept from a while ago. You see? That object survives from here to here. And it kept a reference on a field to the same instance. My God, right? And it changes the field. These are frameworks typically doing that. Assigning fields or changing proxies or stuff like that in your entity model. Right? Hibernate does that with setting your ID. So this is, however, due to the fact that this data lives for a long time. Data traverses a lot of code. Many people use that in that object. That's the horror story we live. And you are typically forced to enter breakpoint mode. You see, where was that option? And you breakpoint on the setter, that kind of stuff. What the heck, right? You have actually to determine what code ran before I got here. Wherever it would be, everything. What ran before I got here? Which is very hard to find out. Now, what would happen if this data would actually be immutable? Let's play that. But if it's immutable, there are no setters, right? So, of course, if there are no setters, I don't care to who I give my instances. So this also gets removed. I don't need to look in those places. So the only thing I need to look at is where my instance came from. Pack and pack. Done. Logarithmically less space to search, if you want to put it in a computer science term. You only need to find out who created the instance. Right? Easy to trace data changes. Very easy. Right? Oh, there will be some functions in between, but not the end of the world. Right? You can trace. And actually, IntelliJ has a very interesting analysis tool. It's called Analyze Data Flow to Here. Look, this pointing you to the play with these ones. Analyze data. These one are lifesavers in legacy code. Lifesavers. Good. Now, let me write with you some immutable class. Okay, this is it. If this were an interactive training, I will ask you if this is immutable, and you will say, no, it has 5 linked fields. What's wrong with you? And I will encapsulate the fields. I will use a lot of refactorings. These will be displayed, the shortcuts in the corner. You can watch the recording, and also you can find on my website. I have a website. That also have a website, a very beautiful website. I did it myself. And by the way, I'm a backend developer. Can you imagine how a backend developer site looks like? Bad, of course. But the point is here that I have a cheat sheet with the shortcuts that I use. All the shortcuts that I use today, which here is there, right? Good. So I'm encapsulating fields. Cool. Refactor. Set. Yes, that's the first thing. Public fields. Who uses that? No. Private fields, of course. You know this from childhood, right? Right. But then the setters really to be immutable. It means you can't change it. So the first thing you would be told to do is make all the fields fine, of course. This will require you get all of them to the constructor. I didn't, again, I get the constructor for me, okay. So I need to pass 1 as the constructor, and other here as the argument. Perfect. Yeah. So because I have final fields, I can't possibly have setters, right? So there we go. I don't have any setters, right? But then wait a second. This is busy, right? It will get interesting very soon. But what about is this really now immutable? It depends. And some people now look at other and say, wait a second, is this one immutable? Let me check. Oops, no. Now, one could argue that this one is shallow immutable. It is immutable in its own state, but not deep immutable. Because you can do the following. Immutable dot get other dot set a to a different value, 14. And if you run the code, you don't see 15 when I print it out, you will see 14. It looks nothing because it doesn't have a 2-string. So let me do it a 2-string. So you will see a different value there. So of course, to get deep immutability, to be able really to say that it is immutable completely, you have to go there and make that one also immutable. So you have to point this out. Right. That's the entry point. Most people, if I ask them to write me a immutable class, they will tell me that. Some people will ask me, what about this list? What if someone evil someone evil along the way here or here does the following: get numbers, yeah, clear, yeah. Then what? It's because in Java is an old language, you know that, right? In Java, the collections are by default mutable, changeable. So to get this actually to block the edit of the list, so here's what happens, right? Because I expose the list that I have inside, they can clear it from outside, which is not good. Some people tell me, make a clone. Yeah, but this wastes memory, right? This is a malloc. This is allocating memory. What? I don't really need that. I will clone the list every time. It's inefficient. That's why the actual really widespread solution is this. It's so widespread that it's become part of intelligent suggestions. A modifiable list. And of course, because it's DDK, a modifiable list, the subject import. So this basically creates a decorator on top of the list, of the original list, which blocks any attempt to change it. There you go. The clear in the thing that I got back throws the exception at me. Now, the interesting thing is that there is no cloning. The clear throw exception. There is no clone happening under the hood. There is no memory allocation really for the array. Interesting, very interesting. Another stupid thing. Let's leave it at that. So this is one technique you could use. Yeah, but the bad thing is that it crashes at runtime. However, it's not that dangerous because really, once you test that code at least once to see that it saves, that's why it's clearly the most widespread solution. But there is another one, which is interesting really, because it's more type safe if you want. But again, remember, this is the most used one. Now, why do you expose the collection outside? Probably for someone to do a forward. Now, by the way, that's called postfix expansion. I typed .4. I have on my website a YouTube playlist of YouTube talks, among which you can find with YouTube with me showing tricks with IntelliJ. If you are curious about that, ask me on Twitter or something, and I will share with you. So number, I'm iterating over it. Let me try to let me show you another postfix. Number out. Okay, so what would this do? I need to be able to iterate over those. Right. But as you know, the only thing we need to expose to iterate is an iterable. Interesting. Interesting. That could actually work. And it will be clear from the signature that you are not allowed to change it. Why? Because if you ever want to do that, this doesn't compile anymore. My friend, there is no clear and iterable. It's a middle ground which builds a more suggestive model, if you want. It's clear, it's iterable. I can't change it, right? It's iterable. I'm supposed to iterate. Okay. Right. There is one more geek for, but I won't go into. Now, there is one more breach left. But I call it breach on purpose. It's a hack. You see, let me show you. It's so interesting. I'm sorry to say that. What the heck am I doing? I am passing numbers to this constructor that's here, and I am assigning it in my field. Right. And then afterwards, on the same reference, I clear it. Oh my God, who does that? I changed it. When I created it, it had 1, 2, 3 as values. But then at the end, when I print it here, it's empty list. Why? Because I kept the reference to the arrays. This is the closest thing I could imagine to hacking. This is hacking. To defend against this, there is no way other than doing the following: a clone. There is no other way to defend against this hacking. But this wastes memory. This allocates memory. This is bad, right? But to be honest with you, perfectly honest, I don't like that. Because really, what are you defending against? Are you defending against someone keeping a pointer to your objects, to your collection? And because Java collections are inherently mutable, it changes it afterwards. It's insane. I mean, what are you doing, right? The problem is that the real danger is not where you create the object, but the path that it traverses. The risk of this to happen to you is very, very little. That's my point here. However, if you really want to go the whole path, go to Guava collections, Guava, or immutable list. From Guava, I don't have the Java, but it's there. Right. Or use Scala, whatever. So Java is not prepared really to do that. So this, however, I would say, don't do that. I showed you the problem, but don't do that. The risk is not there. The risk is along the way. If someone gets and clears this. This is the risk. This is the risk. Right. Now, since you got there, it's very easy to actually make sure that the other is never left null. Require non-null. And when I assign it, I also take in a single line that this never is past null. Java 8 objects. Right? Very interesting. I can do the same for this, because what purpose does it have to have a null list? Who does that? I will fire that guy who does that. Null list? Really? No. Empty list at once. Good. Right. But then, okay, that's an immutable object. You can possibly change it. But what if I want to change it? What do you mean? Yeah, I want to leave the state as it was, except X. The only possible way to do that is to instantiate a new object, of course. This is the same thing that Java does, right? A string is immutable. If you request to uppercase, it will give you another string. The same thing, new immutable. But you see, inspiring from Java, why not letting the immutable itself have a method with a new X? The original one was what was 1, 2, 3 X. And I expect this will return me back another immutable. Interesting. These are called vectors, by the way. New X, right? What do? I will instantiate here new X, the old numbers, and the other which I haven't in. Perfect. Right. This is it. This is how you change immutable objects, by creating a new instance. Now, just for fun, I will commit this. By the way, you have a brand. I will share with you When is the best? I think now is the best. Here we go. So manage remotes. This is the. I can't paste to you folks, but look at the code. This is the gift, and this is the branch. On this branch, I commit now. Classic Java style. Immutable objects. Now, let me make it shorter, shall I? You may not be a big fan of it, but I am. So to string, deleted automatically. Get deleted automatically. Not this one, because this I want to leave immutable list like this. Maybe I want to change it in an immutable list. And an unmodifiable list. The constructor, because they are final, it's or automatically generated. The question is, how do I preserve these? Interesting. Okay. No. Okay. Delete. Done. Delete. Right. No. Wait, I need a width. 2 weeks. What do you mean width? It's exactly the same thing. Please say what am I showing you? I'm showing you nothing. I'm showing you. Oh, by the way, you can get better. Value. This become redundant. What are you doing? And the next step, you know what it is? Record Java 17. Take it. But let's stop here because this is quite interesting. Tick, tick, tick. Done. This is an immutable object that you want to have. Doing exactly the same thing. Right? Lombok magic. If you don't know what Lombok is, I read into it. More than 80% of my clients are using it. I also recorded on my community a little tutorial of best practices of using Lombok in production code, and I also have some blog posts on that. So document if you don't know about Lombok. Right. So to continue the idea. So if you ask anyone about immutable objects, they will tell you, oh, final fields. Yeah, of course. But also make sure that the objects that you refer to are immutable. Right? The constructor can do this, can clone the array, but this is overkill, as I told you. It's not really the problem. The problem is the man in the middle. Right? Then you can put some validation like we did, right? With not null or yeah, whatever. You can return an unmodifiable list, right? No, the audio is bad. Let me check. I am on a wire, so let me check. I have 40 megabits per second, so my audio is perfect. It's not me. Let me just check. Maybe I can. 1 second. Let me check one thing. If I'm using the right microphone. How do I check that? This should be the microphone. Hey, oh my god, it was my fault. I'm sorry. I should this one. Now it should be better, way better, like in radio. Sorry for the issue. Right. So now it will be better. Right. Then I also showed you iterable, and if you want to be geek, try this one. This is insane. Now hash code equals in all fields. If you do that, you get what we call a value object, because that's the definition of a value object. It checks equality based on all fields. Right. Now, record will give us for free this. You should have told me earlier, Marcus. This gets you for free getter hash code equals to string everything that we saw. Until we get to our hands, probably next autumn when Java 17 long term will be there. Until then, Lombok value will do the magic for us, right? Like I showed you. Don't make your class final. What are you afraid of? Hackers? Who will subclass this? Come on, no. And withers, of course. And I showed you how to do that by creating a new instance. Yes, that's it. But now, as soon as you see that you can really change an immutable object, now you have ideas. And look what happens. Anytime you want to change X, you need to return the data. You see? So if you want to change X, you need to return the data. Ouch. Oh, then I can do this. I want to change X, Y, and Z. I keep returning the data back. And now imagine the data object has 20 fields. Happens. We are in the same garbage as before. Who let the dogs out? not sure if you can read this. I'm not sure if you can hear this, but the problem is still there. Who changed the field X? You have to trace through all the functions to find out. Now, there is an interesting, the mess is still there. How to fix this? Immutable object need to be applied with an immutable mindset. The obvious problem here is that you are reassigning variables. Final variables will fix this for you. But personally, I would prefer to rely on the underline with IntelliJ puts underneath, right? This is what, whenever IntelliJ sees you reassign a variable, it will underline it. Mind that underline. Let me show you. Look, immutable, it is underlined. If I wouldn't reassign it, it's not underlined. Look careful. Right, this is one way to do it. Final keywords are a brutal way to enforce that, but they will pollute our code. That's why last week I heard 2 weeks ago, I had a client who used error-prone Java compiler from Google, and in case you ever, so basically that compiler will fail compilation in case you ever reassign a variable. If you really wanted to do that, you will have to put var from error-prone library. It's a bit of much of configuration to do to make it work, but the point is that it should be so extraordinary that you change a variable that you should mark the changeable variables, not the immutable ones. So don't put final everywhere. Instead, mark the. It's hard, really, but that's an extreme. However, this is just the symptom. The real problem is that your immutable object is too big, has 20 fields, and you have to update parts of it in many places. That's the problem. That's the real problem. And the real solution is to break them, is to break the immutable objects with 20 fields into smaller objects. Now, you can easily survive, and I've seen entities, Hibernate entities, with 50 fields. I've seen hundreds of fields from legacy systems. You can survive with that, but you can't survive with immutable objects with 50 fields. Seems to be what? Private or what? I don't see that. Keep chatting. Then the solution here is to encapsulate XYZ in another object that you put on data. You see what I'm doing? I'm applying this principle. If they change together, they should stick together. Right. But this guy has another issue, has another idea. He passes an array inside the method. Who does that, really? First of all, who uses arrays these days? Really? Just about the code, I will share the code that I wrote with the JUG leaders, and they will post the zip on the community page. So don't worry about the code. I will make it. This one. We use lists, not arrays, but we remove from lists. Don't do that. Don't do that. And I want to show you the most horrible thing I ever saw. Multiple times. They took stuff from a map, they changed the object, and they put it back on the same key. What the heck are you doing? What the heck you are overriding? This is like, oh my God, this is the panic moment, you know? Don't ever mutate collections. Do not do that. God gave us stream API. Create new collections, collect list, create new collections, do not change existing ones. Do not change, do not mutate collections. Most of our pain comes from elements disappearing from entities, from lists. So why do we love immutable objects? Because it's easier to trace where they change. You don't need to trace who set the field, but just who created the instance. You can enforce validation in constructor like we did, which makes our model more robust. Okay, today we don't even see the constructor, but it's there in the bytecode. It's safe to put them as keys. That's a creepy one. I don't want to show it. I don't have time for that. And also thread safe. Thread safe because it's immutable. You can't change it, right? Right. So that's it. From now on, only immutable objects, right? Folks, I've been to more than, I think, almost 50 companies. 50 companies, hundreds of teams. Only one company I saw, they made their entire entity model immutable. Most applications, for the vast majority, is too much. The real question that you need to ask me now is, should entities be immutable? No. Immutable should not, hibernated entities should not be immutable. Instead, what I wanted to use immutable objects is that you should extract immutable value objects, little objects, to group some of the fields of those entities, leaving the root entity mutable. Let me explain. The root entity, the user, is mutable, but the full name of the user is an immutable embeddable in case you are on Hibernate or an ORM. This is like a piece of data, so a grouping of data, which is stored in the same table as the entity. It's magically mapped in the same table. Right? This is the best feature of Hibernate that you didn't use before. Embeddable. And it allows you to model full name almost as immutable object. It's effectively immutable. The only thing Hibernate will not be very happy with this is that there is no default constructor. So you can add a no-arg constructor, but you can make it protected. It's a bit out of scope. It's too much to show, but you can. And your goal will be then to extract more and more stuff from the root entity into little immutable leaves. Right? Now, besides that, there are some other objects which traverse our logic, which are those objects that never get to the database. Those objects, those runtime objects that we just use to write some logic on, and we never persist. And I want you to make 100% of those objects immutable. All the objects that you do not persist but contain data should be immutable. I repeat, all the objects that don't go to the database but you work with to implement your logic, all those objects that contain data should be immutable. That's it. Because that's the big deal. That's the big deal. When you have a long workflow and deep inside someone changes a field. I'm coming back to the pure function now, right? If this changes a field, then this is impure, impure. Nothing is pure. It's bad. What I want you to do instead is to extract some value object from the E, pass that immutable value object inside, which will allow these functions to remain pure functions, computing data and returning data back. Folks, it will take 3 more minutes. Mind that it's only 1 minute to sharp, in case you have other issues, other. So I will then return back the thing and set it on the field. Set it on the field of that mutable entity again. But this lives in the imperative shell, while the majority of my logic became pure. Right? There are some tricks here, because I told you, when you want to return more values from this processing, you might actually try to need to create a new class to host whatever changes on that flow. But again, folks, I'm talking about those 10-20% most complex use cases. This is not to apply everywhere. But the big deal is when immutable objects travel a lot of code. And you think now about immutability. In short, it will not matter. I challenge you to measure it. You have a surprise because these objects are very, very lightweight. They get garbage collected very fast. However, it is indeed a bit strange if you do trash millions of instances per second. If you really do this hundreds and millions of times per second, then you have a problem indeed. Don't do that. Don't use immutable objects for that. Don't use immutable objects if you get to clone a lot of collections. I didn't show you how you can change the collection. By cloning it, of course, you need another array, basically. And if you get to clone a lot of collections, then that will get you into garbage collection issues. If you have a very trivial logic, don't make it immutable. Doesn't matter, really. There are no risks there. Persistent entities or data transfer objects that you send and receive as JSON, these don't deserve to be immutable. You don't care about those. Right. So, coming to the conclusion, what should you take away from all this? First of all, anything which is complex, any logic that you are afraid of, implement it using pure functions and immutable objects. Pure functions and immutable objects. I mean, create new little objects extracted from those entities and pass those entities, those value objects in your logic. Don't do database calls and network calls from your logic and return values back. Promotion mechanisms, price computation strategies, stuff like that. And you isolate the most complex logic in a functional core, surrounding it with an imperative shell which does the dirty work. Right? And then, of course, take all the dirty database and network calls outside of your functional core. Okay, put it out at the top level. When you first enter in a use case, and the first method with logic that you see should do all the network calls and database interactions. And as a mindset, don't just change it in there. I know it's easier for you to do that, but instead try to compute some values and return some objects back, and you apply those objects in the imperative shell. Deep stuff. Without proper mindset, immutability can hurt. Remember this guy and the ideas he had? Immutability misunderstood can do more harm than good. Don't change arguments inside that method. Don't change variables. Don't reassign variables, and don't mutate collections. Never do that. It's so bad. And again, immutability, use it for runtime data or 100% or parts of your persistent model. And if you dare are to take one single line from all this, stop changing stuff in there. Instead, compute and return. That should be a mindset. If it's difficult, don't change it there. Let me put this field to true. No. Return something back. That being said, my slides are done. In case you have questions, and you should have questions, I'm talking about deep stuff. This you can apply on all of your projects. Every project has some complex parts. Use these. Now, on the commercial part, if you want some training for your company, this is the website. Google me. Any questions, folks? Please. You were eating them.
Any questions? Maybe there are some people that are just watching the session on their TVs, and they don't have.
Yeah, I would do that. Really. Yeah, look at this guy. Yeah.
I will also encourage them to read to you
please.
if they have with any questions.
Twitter is best. I am most responsive on Twitter. I could also do emails if you want. Just ask me anything which is nice. I know it's been a lot of stuff, indeed. Yeah. Try to apply this to your production and tell me what you think. Tell me where does it hurt? What doesn't work? I will ask myself one. Yes. I will ask to just finish with one little thing. Show you how you can do this with Hibernate. This becomes embeddable and needs a constructor. An immutable. This no longer can be final, unfortunately, but this constructor that you create here, leave it protected. That's the only trick really that you need to know of. So protected. And only Hibernate will call it. There you have a little bit of. Yeah. Is it okay to say that the impure function is a function that takes a universe as a parameter? If you try, Kotlin manages immutability perfectly well. Haskell is the state of the art. Scala is also much into this. Let me see. So let's start with the question for universe as a parameter. You get to take the universe as a parameter if you depend on the entire universe. Pay attention. It's tricky. It's really tricky. So let me put some slides to have something to paint on. Just a second. If this function here needs to take dozens of parameters, and in case every such parameter has 20 fields or 5 fields each, and of course you can say that it takes no, Carlos, you are right, but that's actually this is the pain point. If you get to take 5 big objects in a function, I will definitely ask you, how many things do you really need from those 5 objects? Isn't it that you really need 1 string from here, 2 integers from here, 1 from here, 1 from here, and 1 from here? Then if that's the case, wouldn't you really want to extract this as another object? Because if this processing is so complex that you want to make it as a pure function, then you might want to very clearly delineate the inputs to that function. And that's a very good reason to create a new class, a parameter object, but not everywhere. But if that's the case, if you just cherry pick several of the informations, it will help you to understand the function. Oh, this function needs these things. And of course, I don't tell you should take 5 or 8 arguments. No, up to more than 3 or 4, it kind of pays to create a class. So Carlos, your question was really hitting on the most painful point. You need to create a class. Yeah. Okay, I think Kotlin provides some syntax sugar for immutable object under the hood. Yes, indeed. And they will update Kotlin when records will be mainstream. So what I mean here is that when you do, let's play records. Why not? Just several. In case you never saw them, Kotlin folks will be just so glad at that moment. And maybe we'll come back to their mother, to their roots. Let me 15. 15, but you don't say that, you say release. Good. Right. Import Maven. Let me just change it to 15. 15. Good. And then let's convert this to a record, shall we? Well, you don't really need this anymore, record. And then the Kotlin will be very happy. Yeehaw! It's integer number. That's exactly as Kotlin and Scala, case classes from Scala. These languages, they all converge to one another, you know? You can't really express these non-null constraints, but with a bit of luck, yeah, kind of start working. That's it. And the only thing is that the getters are named differently. They dropped the get convention. And to mutate, you need to do your own wizard. But here, it works. And I'll push this, but you won't be able to compile it yourself. I need a wizard here, however. Record, Java 15. They will be with you next autumn. New immutable of numbers and other. Done. And it's Kotlin. +3 hash code equals getters everything. Cool. Any questions? Come on. Very interesting until now. And Carlos hit the pain point perfectly. Right. I don't know exactly the bytecode that Kotlin generates, to be honest. I wasn't curious. This comparison. 15. Right, folks, any questions? Come on. You have 10 seconds to ask me questions. 10, 9, 8. If not, you can reach me afterwards, of course. I like to do this. 4, 3, 2. Sugar syntactic. Yeah, you could look at the bytecode and yeah, the slides. I will share the slides with your JUG leaders and they will share with you today. Bytecode. I need to compile it first. Bytecode of this one. You really want to see the bytecode or the decompiled code? I would like to see the decompiled code. I'm not that geek. So let's go to the decompiled code. Yeah, classes. Where was I? Pure. Victor, pure. Immutable class. What's the fun fact? The decompiler previously didn't know to decompile it as a record. But look, it still has all the generated bytecode inside. You see together? My getter, really. These are the generated ones. X, other. And it doesn't show you the two-string equals and everything. It's there. The best way you can really see what's in the record is to press Control F12. I'll show you in a second. Control F12, outline. The immutable inherited will have a two-string. We'll have equals and everything. Yeah. Right. Thanks a lot for being with me today. And maybe hope to see you some other days with another occasion. Who knows?
Yeah, that would be great. Thank you, Victor. And people, I have another question I have received by another channel, by a private channel. And someone is asking, what do you use for preparing the slides, and what tool do you use?
What the heck is that? Huh?
Yeah, that's for presenting, to do this kind of markups.
Zoom it from 15 panels, free tool, Windows only. Drawing on the screen. Okay, and to prepare my slide is PowerPoint. But I have a lot of experience with PowerPoint. Yeah. A lot of experience.
Okay, and regarding the slides and the code, as you were saying before,
sure.
if you send to us, we will publish it on our
the slides and the code, everything that you saw.
Perfect. So, thank you very much. And before closing the session, I would like to announce another. Just let me share my screen because after this great session, we are planning to schedule another one which is basically scheduled for this month, just in a couple of weeks. And we are going to do something. We are going to try to dig a little bit more into TDD. Thanks to Nacho Cogil, coming from Barcelona, and he will basically. I just written the schedule, the meetup, and we are going to announce it right now, right away after we close the session. But we wanted to announce our next session. So in case you are interested, just join us for the next session.
Can I add something about this? Just a thing. Software craftsmanship means basically refactoring clean code in TDD.
Yeah.
What TDD is really good at, I mean, if you just look at the TDD kata, okay, it's really interesting, but nothing increased my skills as TDD. You hear many people saying that, but es en serio. I mean, really, why? Not necessarily put in production. TDD changes, frees your design. It makes you see more, way more. Yeah. So although it may seem boring and hard at first, give it a try. There is nothing which can grow your skills as much as TDD. Trust me, I'm teaching that.
I always quote a former colleague that used to say that not using TDD is for him was like going to work naked, completely naked, without any clothes.
I know, but it can sound as a religion. It's not that. It's a way to improve your skills. See it like that.
Yeah, but it's also about the security that gives you
I know, the safety. Yeah, that's what really the best thing. We can refactor whatever. You don't like it, refactor, but the test will still break, and they will be frustrating also at some point. Okay. So it's tricky. It's tricky. The best to do is that you grow your skills so that you don't really need that much testing in the future. Listen to JBrains if you want to understand these ideas. Yeah. If it's mandatory in a design flow, then whoa, congratulations. Are you hiring? Yeah, great.
Okay, so that's a good way to end our meeting, and just hoping to see all of you in our next session. Thank you very much again, Victor. We need to invite you whenever this social distancing thing finally ends. We would love to have you both in Madrid, Vigo, and Coruña. We can try to, and I'm pretty sure that some other Java user groups in Spain will be happy to have you. So we need to work on having you here in Spain.
Thank you.
Different Java user group. Thank you very much, and thank you everyone for attending.
Okay. Have a nice day and a nice afternoon. Bye-bye.
Bye.
Right. So now it's